All right, welcome back, Titans. Here we are for some homework review with factoring out the greatest common factor. Miss you guys, hope you're doing well. Want to give a shout out to my IM2 students especially. Hopefully we'll see you back in like a month or so. But who knows? Until then, let's keep doing math online and make sure you're doing your work and call your friends, make sure they're doing their work. Let's all keep this rolling. So number one, factoring out the GCF. First, we need to look at the 20 and 24 and determine what's the biggest number that can go into both of those. Some people might initially say, well, 2 goes into both. But the problem with that is there's a bigger number that goes into both of them, bigger than 2. So when I look at 20 and 24, I know that the biggest number that goes into both is 4. So if 4 goes into 20, it also goes into 24. Then you have to look to see if they both have the same variable. Both a squared and a are present in those terms. So since they both have an a, we can take out an a as well. When we decide how many variables we can take out or what exponent to put on that, we can take out whichever one has the fewest of that exponent, so the smallest exponent. Since this one is a to the first, the most we can take out is a to the first. So 4a is called our greatest common factor, GCF. To continue factoring, we need to put what will go in the parentheses so that it multiplies back to our original problem. So a couple ways you can do this. I usually just kind of do it with mental math. I go 4a times what would give me 20a squared. So I know 4 times 5 would give me 20, and then a times a would give me a squared. So if I do 4a times 5a, that gets me back to the 20a squared. Then for my second term, I have 4a. I already have the a that I need, so I don't need another a. But to get to 24, I'm going to need to do 4 times 6. So 4a times 6 is 24a. And this has now been factored completely. And again, you can always double check by distributing your answer. So if I distribute this, 4a times 5a is 20a squared. 4a times 6 is positive 24a. And then another thing we should do when we double check our answer is make sure that there's no common factor in the parentheses. So when I look at 5a and positive 6, they don't have a common factor other than 1. So I know that the 4a was the greatest common factor. If I had something like 5a plus 10, where I had a number that went into both of them still, then I would know I didn't get the GCF. But on this one, 5a plus 6, they don't have any common factors other than 1, so we are good. Depending on your teacher, they might also have you write the problem out. So if I go back to the original problem, 20a squared plus 24a, another way to find out what's going to go in your parentheses is you simply divide each of these original terms by your GCF. So I can divide by 4a, divide by 4a. And if I do that, 20a squared divided by 4a is 5a. So you can do 20 divided by 4 to get 5. And then a squared divided by a is a. And then we could do that again. 24 divided by 4 is 6. A divided by a, they just cancel out. So 24 divided by 4 is 6. Again, just the second way to go through that problem. But in the end, we end up with 4a times 5a plus 6, which was C. All right, the next problem we're going to go through a little bit quicker. I'm not going to explain quite in depth, but hopefully you'll be able to pick it up as we go. So when I look at 20k squared and 4k, the biggest number that goes into both is 4. And then both terms have k. And this one has the lowest exponent, k to the first, so that's all we can take out. Can't take out k squared because this one only has k to the first. I can't take out squared if it doesn't have that many. Then we're going to put our parentheses, and however many terms we start with, that's how many terms have to go in the parentheses. So that's just a good thing to keep in mind. If you start with 2 terms, your parentheses will have 2 terms. 4k times what will give me 20k squared? Well, I know 4 times 5 will give me the 20, and then k times k will give me the k squared. So if I multiply those together, I'm back to my 20k squared. And then 4k, I already have 4k. So some people are tempted not to put anything here. But if we started with 2 terms, we have to have 2 terms. So we still do the same thing. 4k times what would give me 4k? Well, that's 4k times a positive 1. So we end up with 4k times 5k plus 1. Again, to check your answer, you can distribute. That's 20k squared plus 4k, which is what we started with. Beautiful. Moving on to number 3. Number 3, 21 and 27, their greatest common factor is 3. They both have an x as well, so we can take out an x, which leaves me with 7x, because 3x times 7x gives me the original 21x squared. And then 3x times 9, 3x times 9 will give me 27x. So this is factored completely. There we go, it's C again. 9x squared minus 6x. Biggest number that goes into 9 and 6 is going to be 3. And then again, they both have an x, so I can take out x to the first. To get to my 9x squared, I need to do 3x times 3x. And to get to my negative 6x, that's going to be 3x times negative 2. So 3x times 3x minus 2. That one was B. All right, 14b squared minus 18b. If we change it from x's to b's to w's, it doesn't matter what letter it is. If they're the same letter, then we just treat it kind of like an x. We just write b because it's a b. When I look at these, 14 and 18, the biggest number I can take out is 2. And then they both have a b, so 2b. That is called our GCF. And then 2b times what will give me 14b squared. That would be 7b. And then to get to negative 18b, I need 2b times negative 9. Again, one way to double check, if I check what's in the parentheses, there should be no more common factors, which there are no common factors that go into 7b and negative 9. So I know I picked the right GCF. And I've got 2b times 7b minus 9. Number 6, we can take out 2v, which leaves me with 3v minus 2. And again, to double check that, distribute, that's 6v to the second. Distribute, that's negative 4v. And this should always be what I started with. Boom, it is. So 2v times 3v minus 2. All right, 10v squared minus 12v. Excuse me. I can take out 2v. 2v times what will give me 10v squared? Well, that's going to be 5v. 2v times what will give me negative 12v, and that would be negative 6. So 2v times 5v minus 6. Hopefully you're getting the hang of these. Taking out the GCF is pretty straightforward. Again, we look for the greatest number that goes into 10 and 45, which will be 5. Both of these have at least n to the first, so I can take out n to the first. Put my parentheses, started with 2 terms, so I have to have 2 terms in my parentheses. 5n times 2n will get me back to the original 10n squared. And then 5n times negative 9 gets me back to the negative 45n. So there's my factored expression right there. All right. Man, we're making these too easy on you. 15 and 18, common factor is 3, and then x squared and x, we can take out x, which leaves us with 3 times 5x. 3x times 5x gets us back to 15x squared. 3x times negative 6 gets us back to the negative 18x. And there is our answer. Here's one that's a little bit trickier. When I look at that, at first I might think that the GCF is 2. And I'm going to show you what happens if you pick the wrong GCF. So keep in mind, I'm not going to get to the right answer until the end. First, I'm going to show you a common mistake. That's not technically wrong, but it's not fully factored. So a common error would be to take out 2r, because 2 goes into both of these. And then if we take out 2r, this would be 9r plus 24. And so some of us might think we're done. But if we look at the parentheses, what do you notice about 9 and 24? I'm going to wait for someone to answer. Just kidding. All right. 9 and 24 still have a common factor. There's still a number that goes into both of those. We could still take out a 3 from each of those. So if I can still take out a 3, that means that 2 was not my greatest common factor. So if I could take out a 3, and I already took out a 2, if I multiply those together, I know that my GCF is actually 2r times 3, which will be 6r. So that was not factored completely. But if I take out 6r, and I redo the problem, 6r times 3r will give me the 18r squared, and then 6r times 8 will give me back to the 48r. So 6r was actually our GCF. Although the 2r multiplied back to this, we didn't take out our biggest common factor, our greatest common factor. But now when I look at my parentheses, the 3r and the 8, there is no common factor for those. So I have taken out the GCF, which is good. That's what we want. So my GCF was actually 6r, and then our remaining binomial was 3r plus 8. Number 11, GCF is going to be 2n, and then to get 4n squared, that's going to be 2n times 2n, and to get negative 10n, that's 2n times negative 5. I double check, no common factor, that's good. If I distribute this, I get 4n squared minus 10n, which is what we started with. That's perfect. So my final solution here, 2n times 2n minus 5. And then our last one, number 12. Oh wait, not last one, I lied. 18n squared plus 30n. Again, I might take out 2, I might take out 3, because those are common factors. But the greatest common factor for 18 and 30 is going to be 6. And then again, we can take out n. To get to 18n squared, I need to do 6n times 3n. And then to get to 30n, that's going to be 6n times positive 5. So my final answer here, 6n times 3n plus 5. $30a squared minus 36a. Again, multiple numbers that would go into both of those, so we need to find the greatest. Kind of look at your answers to get an idea, right? Well, none of them have 2, so it's probably not 2, and they all have 6, so it's probably 6, which it is. So if I take out 6, and the a, of course, because they both have a, I would do 6a times 5a to get back to 30a squared. And then 6a times a negative 6, because I need to make sure to get negative 36a. 6a times negative 6 is negative 36a. And voila, we've got 6a times 5a minus 6. Number 14, again, more than one factor that will go into 28 and 36, but our greatest is going to be 4. And then the x as well, because they both have x. And then to get to 28x squared, that's going to be 4x times 7x. And to get to 36x, that's going to be 4x times positive 9. So again, I can check my answer by distributing. That's 28x squared plus 36x, and that should always be what we started with. And it is, so I'm feeling pretty good. 4x times 7x plus 9. Since I've got a little space here, I'm going to throw in just a couple of bonus problems just to get you thinking ahead. If we have a problem like 4x plus 8, you notice that the 8 doesn't have an x. So now our greatest common factor will not have an x. So it is possible that your greatest common factor is just a number. So in this case, I'd be able to take out 4. And then to get the rest of this, 4 times x would give me 4x, and then 4 times 2 would give me 8. So again, another example of taking out the GCF. Sometimes you'll also run into problems where your common factor has no number. So in this one, 1 and 4, the GCF will be 1, which we don't ever show a 1 if it's a GCF. But they both do have an x, so I can take out an x. And then I can show to get x squared, that would be x times x. And then to get 4x, that would be x times positive 4. And then one you're going to see a lot, so I'm going to throw it in here as well, is if you have a quadratic. Let's say it's 4x squared plus 8x plus 20. The fact that it has more terms doesn't change anything. It's still the same process. I have to find the greatest common factor that goes into every term. So for 4, 8, and 20, my biggest number that goes into all of those is 4. And then I look to see if there's a variable I can take out. This one has x squared, this one has x, but this one does not have an x. So x is not common to all 3, so I'm not going to put an x. I am going to, however, figure out what I need to multiply the 4 by to get back to the original. So it would be 4 times x squared. To get 8x, it'll be 4 times 2x. And then to get 20, that'll be 4 times 5. Anyway, so just a few extras there. I'm sure we'll be doing problems like that in the near future. But just so you can start wrapping your head around it. Hopefully you guys are doing well, and we'll see you soon.